Hi everybody, welcome to Unit 5, Video 5, and this one is asking for, I can solve equations containing radicals. All right, so since these are equal signs, we have to get answers. And so whenever you get answers for x, you always want to plug them back in to make sure that they work, okay? So make sure here you're checking your solutions. All right, so remember, we have to do our inverse operation. So we have the square root of 2x minus 1 equals 7. So the opposite of square rooting something is squaring it. So to get rid of this radical here, we want to square both sides. And when we square it, it's only going to get rid of the radical. It's not going to do anything to what's underneath the radical. So on the left, I get 2x minus 1. And on the right, 7 squared is going to give me 49. So then I can solve for x by just adding 1 to both sides. So I get 2x equals 50. I'm going to divide each side by 2, and I'm going to get x equals 25. And again, you want to just check that this works. So let's do some mental math here. So if we plug it into the original equation, the square roots of 2 times 25, which would be 50, minus 1, which would be 49. So then square root would be 7. So 7 does equal 7. So in this case, it works. All right, so I want you to pause the video and try number 2. Okay, so here we got x equals 5. So here we got 2x equals 10. We divided by each side by 2. So x equals 5, and I put a check mark because when I did the check, it worked. Okay, so now with these next ones here, what we have is, again, we need to start by squaring both sides. But in this case, if you notice on the right-hand side, we have an x. So we're going to get x squared. So when we square the left-hand side, we're left with 7x minus 12 equals x squared. So now I have two variables. I have x squared and x, which are not like terms, which means I need to solve this by factoring. So I have to set it equal to 0. So I need to subtract 7x from both sides, and then I need to add 12 to both sides. So when I do that, I get 0 equals x squared minus 7x plus 12. Okay, so now I need to look for the factors of 12 that add to negative 7. And so the factors of 12 that add to negative 7 are negative 4 and negative 3. So I get x minus 4, x minus 3. And so then that means my two answers for x would be x equals 4 or 3. And again, we need to do some checking of this. So if we plug this back in, you want to see if it would work in the original equation. So go ahead and do some mental math and let's see if that works. And yeah, both of them worked. So they both are solutions. So 4 or 3. Okay, so I want you to go ahead and pause the video and try number 4. Okay, so hopefully we got to this point where we got x equals negative 5 or 4. But when you did your check, negative 5 did not work. It's what we call an extraneous solution. So you got a solution, but it didn't work. So it's an extra solution, extraneous, that didn't work. But 4 worked. So 4 is our solution. So that's why I put a circle on x equals 4. Okay, so our next problem here. Now we have radicals on both sides, but we still need to do the same thing. We need to square both sides, and it's going to get rid of both radicals. So I'm left with just what was underneath the parentheses. So I have x minus 10 equals 2x. So here I'm going to subtract x from both sides. So I get negative 10 equals x. All right, so I need to check. So when I check this one over here, I'm going to get the square root of negative 10 minus 10 equals the square root of 2 times negative 10. So I get the square root of negative 20 equals the square root of negative 20. Now, this is true. The square root of negative 20 does equal the square root of negative 20, except that the square root of negative 20 is not a real number. So that means, even though I get x equals negative 10, this is, I can't take the square root of negative 20, so I have no real solution. Because we want to know if there's a real number solution, and so this would not be a real number solution because the square root of negative 20 is not a real number, so no real solution. Okay, so let's take a look at our next one here. We cannot square both sides until the radical is all alone, and right now there's this 7 in front, so we need to start by subtracting 7 from both sides. So we get 4 rad x equals negative 4. And you could square both sides, but I want to make it a little bit easier. So rather than squaring right away, I can move this 4. This is saying 4 times rad x. So I can start by dividing each side by 4. So now that I get the square root of x equals negative 1, I could go ahead and square both sides. So when I do this, I get x equals 1. But when I plug it in to check, I'm going to get 7 plus 4 rad 1 equals 3, which is going to give me 7 plus, the square root of 1 is 1 times 4 is just 4 equals 3. So I get 11 equals 3, which is not a true statement. So since this doesn't work, we say no solution. You could have also noticed at this point here that the square root of x equaled negative 1, and I knew that nothing I could take out would give me a negative 1, so you also could have stopped at that point. All right, so let's take a look at 7. This time it's saying the cube root. So again, we're doing our inverse operations. So here, the opposite of cube rooting something is cubing it. So remember, we're cubing both sides. So when you cube the left-hand side, it only gets rid of the radical sign, right? So we just have what's underneath it. X squared plus 2x equals 8. So remember, 2 times 2 times 2, not 2 times 3. It's 2 to the third power. So this one, again, I have 2 variables, so I know I have to set it equal to 0 to factor. So I'm going to subtract 8 from both sides. So I get x squared plus 2x minus 8 equals 0. All right, so when I factor it, I say, what are the factors of negative 8 that add to 2? So I would get x plus 4 times x minus 2. So again, that's going to multiply to negative 8 and add to a positive 2x in the middle. So my two answers for x are x equals negative 4 or 2. And remember, we need to check both of these. And be careful here because it's a cube root. So when you plug it in here, you would get negative 4 squared, which is 16, plus 2 times negative 4, which is negative 8. So 16 minus 8 is 8. The cube root of 8 is 2, so 2 equals 2. And then when you go ahead and plug in 2, that would also work. So both of these work. So they're both solutions. All right, I want you to pause the video and try number 8. Okay, so when I solved it, we get x equals 21, and when you plug it in, it does work. So these next couple of problems here, again, you cannot square both sides until the radical's all alone. So here, you could square both sides, but it's probably not the easiest thing to do because then you'd be left with x squared. So you want to look at, you want to say, okay, I'm using inverse operations. This is saying x times rad 2. So it's easier if you start by dividing each side by radical 2. Because if you do that, the radicals are going to cancel on the left, and you're left with just x. On the right, you have 8 over rad 2. But remember, we can't have a radical in the denominator. So to rationalize here, I multiply rad 2 to the top and to the bottom. So I get x equals 8 rad 2 over 2. And then I simplify. So 8 divided by 2. So this is going to leave me with x equals 4 rad 2. So then when you plug it in to check here, remember, this is x rad 2 equals 8. This whole thing is x. So you're saying 4 rad 2 times rad 2 equals 8. Because remember, there's an implied multiplication sign between the x and the rad 2. So then when you simplify this, rad 2 times rad 2 is 2. You get 4 times 2 equals 8, and 8 equals 8. So it does work. So this is your solution. All right, so with number 10, again, you want to make it easier. So it's probably easier to divide and instead of trying to squaring both sides first. So when you divide here, you're going to get the square root of x equals 4. And so now we can square both sides, and I'm going to get x equals 16. So then when you check this one, remember, you're plugging in and underneath the radical. So you're saying 2 times the square root of 16 equals 8. So we're saying 2 times 4 equals 8, and 8 equals 8, so it works. So x equals 16. Okay, so for number 11, again, we cannot square the radical until it's all alone. And it's not all alone because there's this plus or this minus 3 behind it. So to move it, we have to plus or add 3 to the other side. So we're going to get this. 3x plus 3 equals the square roots of 7 minus x. So now I can square both sides, but you have to be careful because 3x plus 3 is now an expression. They're bounded by these parentheses. So when we square both sides here, you're not just distributing the square, you're squaring the whole expression. So you need to write it out twice. So 3x plus 3 times 3x plus 3 equals 7 minus x, which means now at this point I need to distribute and see what I get. So here, when I distribute, I'm going to get 9x squared. So 9x squared. Then I'm going to get plus 9x. So plus 9x plus 9 equals 7 minus x. Okay, so when we combine our like terms, we get 9x squared plus 18x plus 9 equals 7 minus x, which means we have to set it equal to 0 and factor it. So we have to add or subtract 7 from both sides and add x to both sides. So now we get 9x squared plus 19x plus 2 equals 0. And so now we have to use one of your methods to factor it. So here you want to use factor by grouping. So remember, you have to make the x and you have to multiply 9 times 2 and say, what are the factors of 18 that add to 19? Well, that would be 18 and 1. So I'll go ahead and show you factor by grouping to refresh your memory. I'll do it up here. So we expand that middle term. So we say 9x squared, 9x squared plus 18x plus 1x plus 2. Okay, so then you want to group, make that a better 2. Okay, so we group the first 2, we group the second 2, we factor out GCFs. The GCF here is 9x. So when you factor this, you're left with x plus 2. Here, the only thing they have in common is a positive 1, so you're left with x plus 2. So then your final form is 9x plus 1, x plus 2 equals 0. All right, oops, equals 0. Okay, so then that means when you set both of these equal to 0 and solve, your answers are x equals negative 1/9 and x equals negative 2. So if you go ahead and plug both of these in, you want to see which one is going to work. And the only one that works here is the negative 1/9. The negative 2 doesn't work. But oftentimes people want to just see the fraction and they assume the fraction doesn't work, but you actually have to plug in and check. So x equals negative 1/9. So that's our solution. But again, you would need to check both of those. And you have a calculator, so you could use the calculator. Okay, so let's go ahead and try number 12. So with 12, again, you always want to say, is there something I can do first? So now remember, these two are in a parentheses. There's this parentheses. So they have a GCF between 3x plus x rad 5. So you want to factor that out first. The GCF is x. So we're left with x parentheses 3 plus rad 5 equals 2. Because the whole point of this is to solve for x. So we need x by itself. All right, so the next thing we do, this is x times this quantity. So the opposite of multiplying is dividing. So I'm going to divide each side by 3 plus rad 5. So when you do that here, on the left, they're going to cancel. So now you're just left with x equals 2 over 3 plus rad 5. But remember, we're not allowed to have this in the denominator, so you need to multiply by the conjugate, which is 3 minus rad 5. So you need to multiply by 3 minus rad 5 to the top and to the bottom. So when I distribute here, I'm going to get 6 minus 2 rad 5. On the bottom, since it's the conjugate, I only need to do the first term, which is 9, and the last term, so minus 5. So then when I simplify this, I get 6, right here, x equals 6 minus 2 rad 5 over 9 minus 5, which is 4. But then you want to go ahead and simplify completely. So remember, these two are in a parentheses. They do have a GCF you could factor out, which is going to be 2. So then once you factor out the 2, you have 3 minus rad 5 over 4. And the 2 and the 4 on the bottom, those can simplify. So your final answer here is 3 minus rad 5 over 2. So that's what you get. So you can say equals x. All right. So again, you want to make sure you can simplify completely. And I'll just tell you that this does work. When you plug it in and check, it will simplify. Okay, so let's go ahead and go to the next page. So on this last page here, again, we want to simplify it completely. So this one, even though these two are an expression, they don't have a common factor because this x is underneath the radical. So what you want to do first is, remember, we cannot square both sides until the radical's all alone. So you're going to want to start by subtracting 3x from both sides. So you're going to get 5 rad x equals 2 minus 3x. All right, so now we need to square both sides to get rid of this radical. You could have divided by 5, but that would have made it a lot more complicated. So it's easier just to square both sides, because here you're going to get 25x. And remember, on this right-hand side, it's quantity squared. So you get 2 minus 3x times 2 minus 3x. Okay, so I want you to pause the video and do this one. You're going to have to use factor by grouping. So you have to remember how to do factor by grouping. We did it earlier. So if you need to take a look at how we did it earlier, you can. So pause the video and solve. Okay, so let's see how you did. So once you got here to 0 equals, this should say 9x squared minus 37x plus 4, you had to factor by grouping or one of your methods. So I just did it, but you could have done the factor by grouping. But when you did the grouping, you would have got this as your final answer. 9x minus 1, x minus 4. So that means your two solutions are 1/9 or 4. And again, the fraction worked. The whole number didn't. So 4 was an extraneous solution. So you got 1/9. Okay, so go ahead and try number 14. So pause the video and try 14. Okay, so let's see how you did. So we got 4x squared minus 7x minus 2. Again, since the coefficient of x squared is greater than 1, you would have had to do one of your methods. So you could have used factor by grouping. When you did that, your final would be 4x plus 1, x minus 2. And then remember, our answers are -1/4 or 2. And this time the fraction didn't work, but the whole number did. So when you checked, you got x equals 2 as your solution. All right, thank you for watching the video.